Okay, so we're doing free response question number 4C. We're asked to find the original y value going backwards. We're given the derivative here, and we're going to undo that. We're going to go ahead and undo that and take the integral to both sides. So to do that, we're going to separate our dy's and dx's to both sides, and then we follow up with the integral on both sides. The integral of dy is just y. The integral of this guy here, oh wait, whoops, I didn't separate them. I need to separate this guy, so we're going to move it over. So it's going to be integral of dy over y minus 1 is equal to integral of negative 2x dx. Okay, so the right integral is actually pretty easy. That's just power rule, negative 2x squared over 2 plus c. And the left side, if you guys remember, it's going to be the integral of 1 over something, I mean natural log. So natural log absolute value of y minus 1. And if I did the chain rule here, the u substitution, that would just lead us to giving us another 1, which doesn't matter. Just to help you guys out, if I want to do u substitution, u is equal to y minus 1, du is dy. So there is no cost there because dy and dx are the same thing. So there's no cost for me to take the integral there. So we just say it's natural log of u, which is just y minus 1, plugging in y minus 1. To rewrite this, so natural log of y minus 1 is equal to, reduce that to negative x squared plus c. Now, you could go ahead and solve for c, as in like move stuff over, but what I like to do is just plug in the x and y values that they have already. They gave us x is 0 and y is 0. If x is 0 and y is 0, those are both 0. Natural log of negative 1 is equal to c. This being positive, natural log of 1 is equal to c. And the natural log of 1, rewriting this, log base e, the what power gives you 1. Anything to the 0 power, just as a reminder, that's going to be 0 is equal to c. So our c value is going to be 0. Okay, so we go ahead and rewrite that back to our original function. Natural log of y minus 1 absolute value is equal to negative x squared. And then we said that's going to be 0, right? So we don't write it anymore. Now let's go ahead and solve for y. I take the, let's see, did they give us anything about y? About y is greater than 0? Okay, so let's go ahead and move the e to both sides. E to both sides. Sorry, left not too far away. We take exponential to both sides to get rid of the natural log. Absolute value of y minus 1 is equal to e to the negative x squared.
So now our next part is to get rid of the absolute value sign. So we looked at problems like before from Algebra 1 when we have absolute value signs. We can separate into two different versions. Example, for absolute value of x equals to 4, we have a x plus 4 and a negative x plus 4. We need that negative to catch possible negative values, to make them positive. Now, going back over here, we can do that with our y minus 1 also. But the problem is when we plug in negative, so when we plug in 0, this is going to be negative. So we have to include that negative value in front. So we're going to choose our option number 2, our negative x there. So instead of writing negative x, we're going to write negative y, negative parentheses y minus 1, close parentheses, equals to e to the negative x. Because we had to use that second version, not the positive version. Then we're going to go ahead and move the negative over to make that negative e to the negative x squared. Then plus the 1 to both sides. Then we have y is equal to negative e to the negative x squared plus 1. Okay, so that's one way of solving. You want to also just go ahead and double check it. Andrew caught our mistake before, and when we plugged in, it didn't work out. So the reason why is because I split the absolute value incorrectly. So when I do plug in 0, we do get negative 1 plus 1 is back to 0, our y value. Now there is another way of solving this type of problem, and it involves us splitting it. Instead of plugging in our 0 right there, we're going to go ahead and solve for y. So to do that, we're going to get rid of the natural log. So without plugging anything in, we're just going to go ahead and get rid of that natural log first. So we're going to e to both sides. So when I do that, that's going to get rid of the natural log, leaving me absolute value of y minus 1 is equal to e to the negative x squared plus c. That plus c we're going to rewrite as when you have a sum of powers, we're actually, as a product of powers. The example is 3 squared plus 5 is the same as 3 squared times 3 to the 5th. So we're making those powers, so exponents when we're adding is really multiplying powers. And then we're going to say, hey, we're going to make that positive. We're going to get rid of the absolute value sign on our next step here. And the reason why we can do that is, the trick is that c value where we said e to the c is really just some constant. And that constant could be positive or negative. And that's really going to take care of that absolute value sign for me. Like before when we split it, we had to be careful if it was going to be positive or negative. We didn't know which one it was going to be till we actually plugged in a value. In this case here, we don't have to worry about if it's positive or negative. That C1, that's going to be positive or negative once we solve the problem, plugging in our initial condition. So if that was going to be negative, version 2, it would have made it C1 negative. If it was version 1, it would stay positive. So that's kind of like the trick, that when you do this way, you don't have to think about if it's going to be plus or minus. That C is going to be positive or negative naturally once we plug in our initial condition. Now, I go ahead and solve by moving the 1 over, or not. We can just go ahead and just plug in our initial condition, which was 0, 0, where x was 0 and y was 0. So if I plug in the 0, y is 0, we're left with negative 1. E to the 0 is 1, so that's just going to be 1. So C1 turns out to be equal to negative 1. That means we solve for a constant, and then we can rewrite this problem with our constant in there. So y minus 1 is equal to C1 is negative 1 now, e to the negative x squared. We can now move the negative 1 over to solve for y. Y is equal to negative e to the negative x squared plus 1. Now we can go to go back in and double check by plugging in 0, 0 to make sure that works out. And that should give us our answer. Now, which way should you choose? The first way or the second way, it's really up to you. The more you practice, the second way is actually a little bit better because that negative sign, we don't have to worry about it. But I feel like it's easier for me personally, the right one. That's when I plug it in and I don't have to worry about this e to the c value, especially if I forgot how to do it. But again, most of the times they actually do the left one.
We're on number 4b. The second way to tell something is a maximum is the second derivative test. Well, the second derivative test is you take the derivative twice, the second derivative, and tell me if it's concave up or concave down. Now, if this graph is concave down, and I told you there's a critical point here, well, that critical point must be a maximum. If this graph was concave up, and we have a critical point, this graph must be concave, up. That means this has to be a minimum. So what they're trying to say is, looking at the derivative here, could you tell me that this is they want you to tell you why it's a maximum. Now, I was doing this using the first derivative, and if I look at the first derivative of this graph, of this problem, if I look at the slopes, if I tell you dy over dx is equal to negative 2x y minus 1, okay? These are all the slopes of the graph. And we're saying when at the y-axis, hey, the y-axis is when x is 0. So when x is 0, that's where the y-axis is. So it's not going to make it positive or negative. And, well, it's going to be 0 there. But what is the slope going to look like? A little bit on the left side, a little bit on the right side. So first, is it 1, a critical point at x is equal to 0? Do we have a critical point at x is equal to 0? If I plug in x is 0, does the derivative become 0? Does it matter what the y is? We said y just has to be greater than 1. If I plug in the 2 there, does that change the fact that the derivative is still going to be 0? No, right? So one thing that we have to first always show if I'm looking for a maximum, that this is a critical point. So yes, this is a critical point. Critical point. And you'll get 1 point for showing that. The second idea is that we have to show, depending which way you want to do, if you want to use the first derivative or second derivative. And I'll show both ways real quick. So I'll show both ways. One way is the first derivative. In the first derivative, if the slope changes from a positive to negative, we have a max. So we know that y is going to be greater than 1. So if y is greater than 1, if I plug in 2, 3, or 5, isn't this always going to be positive? Right? It's always going to be positive. Now, the only thing we have to worry about now is the second part here, this guy here. Will this guy also be positive? Well, let's look at the left side. As I approach 0, from the left side, aren't all these negative numbers? And if I plug in a negative number here, a negative negative becomes a positive. Yeah, that's a positive slope on the left side. On the right side, if I plug in a positive number here, if I plug in a positive number here, that would lead me to a negative value, which means that's a negative slope. Why? Because this is always positive, and this guy changes depending if you're on the right side of 0 or the left side of 0. So on the left side of 0, we said this will always be positive because a negative negative become a positive. And on the right side, this would be a negative. So we do have a positive negative change. So that's one way to talk about it. The second way is to just go ahead and take the derivative again and look at the second derivative to check concavity. So let's go ahead and take the second derivative, dy over dx. So take the derivative again to both sides. So this is the second derivative of y over dx squared is equal to, we're going to do chain rule on that. Derivative of the front, leave the back alone. Derivative of the back, leave the front alone. The derivative of the front is -2, leave the back alone. Plus the derivative of the back, which is going to be 2y dy over dx. And then multiplied by -2x, leave the front alone. So just make sure I did that right. That makes sense to you guys? So the question is, would this be positive or negative slope? Sorry, not positive. Would this answer be greater than 0 or less than 0 at 0? Okay. So one cool thing that we do is we go ahead and plug in our derivative. So we can say -2y squared minus 1 plus 2y times 2x y squared minus 1 times -2x. Kind of big mess. So is dy over dx squared, is this going to be greater than 0 or less than 0 at 0? So if I plug in 0, isn't this all 0 here? 2 times 0, that's 0. There's a 0 here, that's all 0, okay? And what do we say about this number? 2y squared minus 1. Will this ever, is this going to be positive or negative? We said y is always greater than 1. So will this be positive or negative here? Negative. So my second derivative is telling me it is always negative. That means it's concave down at x equals to 0. If it's concave down, x equals to 0, and we have a critical point there, yes, we have a critical point. That means this is a maximum. So that's the process. You show 1, critical point, 2, you take the second derivative, and 3, you show that the second derivative is concave up or concave down. In this case, it is always going to be negative, so it's going to be concave down. So it means the critical point is a maximum.
Where did you get the y squared from?
Where did I get the y squared from? I just copied it when I was doing chain rule. No, sorry, product rule. Derivative of the front, leave the back alone, and then derivative of the back, leave the front alone.
Oh, I think it was y minus.
It's y minus 1. It's not y squared.
Oh, y minus 1? I'm sorry. Whoops. I don't know why I wrote that. Oh, yeah, whoops. Sorry.
So this whole problem was just being able to show that it was like a maximum?
Yes. That's all B is saying. Show me that's a maximum. And there's two ways of doing that. Whether using the first derivative to show that the slope changes from a positive to negative, because you're climbing and then you're dropping. That's why we just left the x. And the second one is our second derivative, concave up and concave down.
And you can do either. You don't have to do both.
Yeah, you can do either.
Okay.
Well, but on the that's what I thought too. But then on the answer sheet you gave us, you get 1 point for doing each way.
Right.
They made you do the first and so do we have to do all the ways? Because on the answer sheet you get 1 point for doing first and then 1 point for doing second. And
so this is one of the easier ways of doing it because it's straightforward. So just tell me if it's concave up or concave down. Now what happens is during the real AP exam, if you show me the other way, that would be okay, and they would have their own grading rubric for that.
Okay.
This way, I think it's just as easy because you just take the second derivative.
No, yeah, I was just because on the thing you get 1 point for doing each way, so you had to do all of the ways.
Mm-hmm.
So I was like, but we don't have to do that on the test.
On the answer sheet that I gave, they only showed us doing it this way, this second way right here.
Oh.
It didn't show us doing the slope, the change of slope between positive and negative. Okay. Did you guys get D?
I mean, I didn't get C, so I couldn't really.
I didn't get C. So I didn't do D.
Okay. So
you can't do D without C.
Oh, you can't do C. Oh, you couldn't? Okay. So one of the things about, D, there's something kind of cool about D. For the solution in part C, find the limit as x approaches 0 of f of x over tangent x squared. Now, when we came up with our solution we came up with it, turn it away. Okay, when we came up with our solution, the solution was y is equal to 1 minus e to the negative x squared. And we're saying limit as x approaches 0 of 1 minus e to negative x squared over tangent of x squared. Okay. So what is the thing that we should always try when we have limits? Should we do something fancy or should we just plug it in?
Plug it in.
Just plug it in, just try it, right? Maybe we'll get lucky. Knowing us, we're not that lucky, so we probably won't get lucky. So if I plug it in, e to the 0 is 1. 1 minus 1 is 0. And tangent of 0, if you guys don't remember what that is, it's just 0. 0 over 0. Does that tell us anything? Indeterminate. Life sucks.
No.
Great. So indeterminate means try again. And we remember we had a way of finding the limit that's really easy. Anybody remember how to find the limit if it's 0 over 0? What should we do and then try again? Does anybody remember? It's called L'Hopital's rule. L'Hospital's rule. And the rule is this. If it's 0 over 0, just take the derivative and try again. We take the derivative. What's the derivative on top? That's going to be, let's rewrite it, limit as x approaches 0 of 1 goes away. Was negative e to negative x squared, chain rule, negative 2x. Okay, look at that derivative. E to the negative x squared is 0, keep it, and then multiply by the chain rule. All divided by the derivative of tangent is secant squared, x squared, chain rule, 2x. So let's go ahead and plug it in again. So the goal is try it, it doesn't work, and then go ahead and try again. Plug it in, so take the derivative, and then try again. So if we do this on top, these divide out, just rewrite that, and we're left with limit as x approaches 0 of negative e to the, sorry, that's a positive now, e to the x negative x squared over secant squared x squared. We're going to plug in 0, plug in 0. That's going to be limit as x, sorry, whoops, we don't even write that anymore. E to the 0 over secant squared of 0. So e to the 0, we know what that is. That's just going to be 1 over. Now, do you guys remember what the secant of 0 is?
0.
Ooh, let's draw it. This is 0 degrees. So the height is 0, 1, 1 triangle. Secant is hypotenuse over opposite. Okay, so I like drawing it out. So my opposite, sorry, not hypotenuse over opposite. It's hypotenuse over adjacent. I'm sorry, adjacent. And there's a hypotenuse. Hypotenuse is 1 over adjacent 1. That's just going to be 1. Answer is 1. Okay, let me go over this one more time. Whenever you're given a limit that they want you to plug in, it's almost going to always be 0 over 0. Okay, unless it's one of those easy level 1 problems. It's almost always going to be 0 over 0. And they do that on purpose because they want you to go, oh, crap, I'm screwed. And then you realize L'Hopital's rule says, just take the stupid derivative. Just take the derivative. And then try again. Okay. Just as a side note, just to prove L'Hopital's rule, just as an example, if I give you the problem, limit as x goes to infinity of 3x squared over 2x squared plus 1. Does anyone know what this graph looks like at infinity?
3 over 2.
3 over 2, good job. Remember that's my horizontal asymptote, right? At infinity, that's like, this is like 3,000 and 2,000. 3,000 divided by 2,000 and 3 over 2. But if I plugged in x, we would end up with infinity over infinity. And that's one of the cases for L'Hopital's rule. L'Hopital's rule says if it's 0 or 0 or infinity over infinity, take the derivative. If we take the derivative, okay, which is 3 over 2, same answer. Okay, so one of the cool things is that L'Hopital's rule allows us to find the limit if it's either 0, 0 over infinity or over infinity. So after I did that, we simplify and then try again here. Try again. Try it again. You might have forgot what secant of 0 is. That's a great time to use your calculator, right? If this was a, they don't care if you use a calculator or not test, just do it. Okay. And that's going to be 1. So you guys have one more FRQ today. That's already posted. You guys can also post up the answers for 1, 2, 3, and 4. Once you guys are done with these, I'm going to post up all 5 again with different numbers. So if you guys want to try this again with different numbers, it's really up to you if you want to spend that time. But I'll post up all 5 with different numbers with the similar techniques to solve them all. If not, what I can do is we can go over other free response questions and I'll release them in about a week. So I'll let you guys forget a little bit. You guys can go back and look at them again fresh.